Hi, everyone. Welcome back to our Getting to Know the Speaker series. Super excited right now for me. We're less than 2 weeks away from the event, so I can't wait to see all of you in person. And today, I'm excited to introduce Dustin Webb. Hi, Dustin.
Hi, guys.
And we've got some great stuff in store for you today while we talk with Dustin about what he's doing. So why don't we just jump in and get started. Um, so Dustin, tell us a little bit about you, kind of how you got into what you're doing today, a little bit of your history.
Sure. It depends on how far back I go, really. I actually started a while back on a robotics degree because actually, if I step back even further, I can say I've been interested in artificial intelligence for quite some time. But it wasn't until around 19 or 20 that I actually realized it is a legitimate research field, at which point I decided to actually go after a degree in AI, right? And even then I hadn't decided on a degree. I had decided that I could teach myself programming. And I did it very well. I ended up with a 10-year professional programming career that was lucrative enough that I didn't actually ever want to quit my job and go back to university. So I didn't. I programmed and I programmed and I programmed and I studied AI and I studied programming and I did a bachelor's degree, not a bachelor's, an associate's degree over that period, like one class at a time per semester, maybe even less. And as I was finishing that up, I decided I need to go back to university and actually focus on this, because if I continue the pace I'm going, I'm going to be retiring before I actually finish this endeavor. So I did. I quit my job and I went to university and I worked for a while at a bachelor's degree, trying to figure out what I should be studying exactly. I know, walking into university saying you wanted to research AI is not very useful, it turns out. And my bachelor's ended up being focused on reinforcement learning and robotics in the computer science department at the University of Utah. And then after that, I went after a master's degree in artificial intelligence. And I was still in the robotics group, but during the course of my studies, my advisor, Yer Vandenberg, got the opportunity to go to Google and be the lead motion planner on the Waymo car, which is formerly the Google car, right? And about that same week, I got an email from Yoshua Bengio at Montreal saying, I need students, I need collaborators, I just need anybody and everybody to work with because he just gotten a large chunk of money. And I actually replied to that, and within 15 minutes I got a reply, and he said, "Let's get on the phone." I said, "Okay." And I jokingly told my partner at the time, "What if we moved to Montreal?" She said, "Okay." And the next day he invited me up to Montreal. So I spent a year in Montreal studying with him and a number of very popular people in the deep learning world. And I learned a lot about deep learning, focused a lot on what's called deep reinforcement learning, because reinforcement learning is a very useful artificial intelligence technique for robotics, among other things. And so since my interests were already heavily into the robotics world, I kept with the reinforcement learning theme and studied a lot of deep reinforcement learning, and then came back and finished my master's degree. And that brings me to, I'm going to graduate and I either need to find a job or I need to start my own endeavor.
Nice. Okay, awesome. So you mentioned deep learning and deep reinforcement learning. What's the difference? Obviously the word reinforcement is there, but to someone who maybe doesn't know much about deep learning, how would you characterize the differences between those two things?
Sure. And this is something that I hope to highlight in my talk. I want to go through the different types of deep learning that are out there and what data you will need in order to use those techniques. Deep learning is, I like to use the analogy of writing. It's learning on top of learning on top of learning, right? Not writing, but reading. So when we look at a text, what we don't see is meaning ever, right? What we do technically see are photons. And there's machinery from our eyeballs in our brain that takes those photons and assembles them into lines, those lines into letters, those letters into words, and words into sentences, paragraphs, etc. Right? Somewhere through the processing that also arises meaning, right? And this is a very good analogy for what deep learning is. One layer processes into lines, the next one, and in fact, we know from the literature that's exactly what the first layer of a convolutional neural network does, right? And then hypothetically, that's compiled into a larger vocabulary of letters and so on and so forth up the hierarchy. Um, then there's reinforcement learning. Reinforcement learning is a different branch of artificial intelligence, and it says that we learn from interaction with the world. We, as an agent in the world, can do something, and then that will change the world around us somehow. Sometimes not, and that might be the change, is it just didn't do anything, right? Um, and that interaction is super important, and that's where the reinforcement comes from, right? Deep reinforcement learning was really coined in a paper from the DeepMind lab, now part of Google, around mid 2014 or so. And it is marrying the two ideas. We're going to do reinforcement learning, but for the learning component, it's going to be a deep model, a deep learning model, right? And that's what you get for deep reinforcement learning. And some of the popular models in this area are like AlphaGo and AlphaStar. You've been paying attention to the deep learning world, especially if you're a reinforcement learner, or really if you're just paying attention to the advances in artificial intelligence, you've seen something about these two things, right?
Okay.
Among many other things that are out there.
Awesome. All right. So just as a sort of tangential question, when you're using your mobile phone and you're starting to type text and it starts suggesting words and other sort of kind of phrases or things you might say, in the whole realm of data science, what mechanism is happening at that point? I always think of it maybe as artificial intelligence. Maybe that seems too far down the road, but maybe predictive text or something. But what's the system involved in doing that?
Depends on the platform. Most of them these days are a type of what I like to call classic machine learning algorithm called a Markov model. They model what letter is likely next given the letter before it, or in this case, what word is likely next given the word that was provided before it. Or some of the smarter ones will even look several words backwards and say, well, we've got these three words in a row. The next word is probably this one. But you'll notice that most of these predictive texts give you three options, right? And so in some sense, they're getting the top three probable words. And if yours is like mine, it learns that I misspell things, and then all of a sudden I apparently misspell certain things a lot. So I just end up getting gibberish for some of my predictions.
Okay, cool. Well, okay, so with that, is there anything that, those of us that, really do like tech and have a lot of tech in their lives, whether it's Alexa's or it's Google Home or whatever tool, you're using, is there a spot where we sort of interact casually with machine learning? I'm sorry, with artificial intelligence, not machine learning, sorry.
Yeah. Oh, yeah. I mean, it touches us everywhere, surprisingly. I struggle ever to come up with examples, but the immediate example is Google. Whenever you go to search for something in Google, that entire backend is an artificial intelligence backend. Google has reformed themselves into an AI company. They used to call themselves a search company. Now they call themselves an AI company, right? Not just when you shoot the text off to search for it, that goes through an algorithm called PageRank, which is arguably an artificial intelligence technique, but also as you're typing in, it's trying to predict for you what the next thing is, going back to the predictive text, right? There's also that Markov model there. Our cars have, it's really, this is where I become opinionated, right? Our cars have a lot of artificial intelligence in them. It's classical control techniques from as early as the 50s, 60s, even older in some cases, at least some of the ideas that are used in our cars fairly heavily, and we use them all day, every day, right? Have you ever walked out, or have you ever traveled somewhere and had your credit card company call you up and say, "Are you spending money here?"
Yeah.
There's an anomaly detection AI running on their servers saying, "This doesn't look like that person's spending habits. What's going on?" Right? And that alert human, right? I'm certain if I put some thought into it, I can come up with a lot more examples as well.
That's cool. I was just kind of curious. And so just to key off that a little bit more, you're part of our data engineering track. We've had some folks already on previous episodes talking about data cleansing and preparation of data, but you always end up hearing ML, AI kind of thrown around like they're sort of the same thing. And then of course I go and throw out an example, which is machine learning and not really artificial intelligence. how do you help people understand kind of the difference between those two things? Because it sounds, at least maybe I'm off base, but it sounds like they're slightly different, obviously different algorithms, but they're different concepts.
This is a great question. One of my favorites, actually. I have a blog post I've been hesitating to publish because I want to get some blog posts in my back pocket before I start publishing regularly. But to the same end, I have a slide that I incorporate in the first few slides of every one of my presentations that says, what is AI, ML, and DL? What are artificial intelligence, machine learning, and deep learning? And this slide, if I can try and describe it, is a Venn diagram. It shows an oval, right? And that oval is artificial intelligence. That is all things artificial intelligence. And artificial intelligence is the set of algorithms that are being written to solve tasks at human capacity or capability, right, or human levels. Machine learning is an oval within the artificial intelligence oval. It is the set of algorithms that try to solve problems like humans do, but with the added caveat that they're going to learn something in the process. There's some kind of learning mechanism in them. Classic AI techniques don't necessarily require learning, just some advanced mathematics sometimes, right? Learning can then be couched as an oval within the machine learning oval. It is a type of machine learning. Every type of machine learning that can be done, I think, has been now put through the lens of deep learning. So you almost might be able to make these ovals one and the same, except the difference is, as I was trying to get to before, deep learning learns on top of other learning mechanisms. So I have some learning mechanism that's learning something, and the output of that becomes the input to another learning mechanism, and that can repeat,
Okay.
however many times useful.
Awesome. Thanks. I appreciate that. I would love to see the slide when you have it ready.
Sure.
So let's talk for a little bit about companies that realize, we need a better artificial intelligence strategy. What we're doing lends itself to, making good use of artificial intelligence. What are some of the things or first steps that you might recommend to a company that wants to adopt artificial intelligence as part of its portfolio of of tools?
Data. This is, I think this is why it's good that I'm in the data engineering track with this presentation, for one, and for two, the history of deep learning is mired in being successful from two different perspectives. One, we got more compute, and two, we got more data. And to this day, we don't know how to do deep learning with a low number of data points. It requires a lot of data points. There's a lot of advanced research in the area of what we call sample efficiency, especially coming out of deep reinforcement learning inspired by robotics, right? To collect data with a robot is time consuming and potentially dangerous for the humans running it and the robot itself. It can hurt itself when it's exploring its possibilities, right? So you want to be able to learn on small amounts of data. The reality is we don't have that down yet. And so what you have to have is data, and you have to be able to manage that data, house that data, all of this, right? So the first and foremost, in fact, what I'm going to focus on in my talk is, what data do you need? How do you get it? Where do you put it? What do you do with it?
Gotcha.
Decide what technique to use with respect to the data you have available if you've already got a warehouse of data. These types of questions.
So when you talk about that, one of the things that popped into my mind was back in my statistics class when we talk about sample size and, sort of that gauge of how many people do you really got to talk to generally represent a large population. And it's a pretty small number, right? Is that ultimately where deep learning and machine learning would like to get to, where they can have if you want to understand this problem, you only need this many data points? Or is there any similarities between those?
Yes, for sure. And I want to kind of approach that two different ways. One, the number of samples you need in a statistical model are relatively low because the number of parameters that you're trying to learn is relatively low. A deep learning model has a lot of parameters, and so we need a lot of data, right? Now, the relationship isn't mathematically linear as we once thought it was. It seems that we're able to train models with billions of parameters with far less data than we would have expected to need, but that we still need a lot of data. So there's an interesting bit of research in that area going on. The other part of that question is interpretability is a really important area of deep learning research, right? And just a theory of deep learning is lagging behind, as classically does in the sciences. We have experimenters out there doing experiments based on observations they see. They make things, and then that yields new observations. And at some point, the theoreticians come behind and say, look at these three, seemingly disparate things. Oh, this is how they relate in this nice, pretty simple way, right? And we're in this space right now where we have a lot of experimental work in deep learning, but the theory is still coming up behind us. And so there's certain things that we can't do. One, tell you how many samples you actually need. It's very experimental that way. If your model's not training, you probably need more data. That's about the best we can tell you, right? Interpretability is also an issue in that these things are still quite a bit of a black box. When it gives you an answer, it's very hard to query it for why. Why did it give me that answer, right? You told me that this picture has a cat. Well, what pixels in the image did you look at? We can actually answer that question. But if it says this person has cancer based on tabular data, it's not necessarily clear how to get that answer from the model, and that makes it the technologies that can slow adoption for the technologies in some areas.
Okay, awesome. And that sounds like a perfect segue, actually, to talking about your presentation. And so your presentation is aptly titled Artificial Intelligence. Why don't you tell us a little bit about what people can expect? Obviously, what we've talked about is, I'm sure, going to be covered to some degree. But yeah, tell us a little bit about your talk and what people should look for.
Well, so AI Influx is the company I've started, AIinflux.com, right? And the name comes from the idea that society is seeing an influx of artificial intelligence, right? We're on the precipice of seeing a large amount of adoption. We've already seen a great deal of adoption, but I feel like there's a tidal wave of it coming. One of my favorite researchers to follow is Andrew Ng, and he was quoted within the last couple of years as saying, AI is affecting the world like electricity affected the world when it first dawned, right? We will see a lot of changes, and what those changes are is hard to predict. What I can also add is that, or what I can add to his observation is that the last 10 years or so of artificial intelligence research, and largely because of deep learning research, has seen a lot of technologies become possible but not yet implemented, right? Another researcher I like to follow is Roland Mimicevic out of Montreal, and founded a company called 20 Billion Neurons. He has a blog post recently on the idea of adjacent possible. Technology is adjacent possible if all of the technologies needed to make it are already possible, right? So it's adjacent to those possible technologies. I've been trying to come up with good analogies for this. And the two that I've come up with so far are, for instance, the cell phone. We would have never got the cell phone if we didn't get radio, right? Radio had to come at some point. And similarly, the car, we needed wheels. We had to get wheels at one point, and then that made the car adjacent possible. But these are not the only technologies in these examples that were required to make these things, right? And for the cell phone now, it's pretty much a requirement. You have a screen, and you have touch capabilities, and so on and so forth, right?
Yeah, yeah. I always find when you look back at sort of the explosion of a new technology, whether let's say that's computers back in the 30s, as you go back further in history, you find things like Boolean math that had no, at least as I understood it, no real applicable value at the time, and then electricity showed up, and it's like, oh, that has a great value, and so it's just kind of cool how those things all come together, and then eventually they cause that new tipping point for something that we hadn't.
I'd like to add to that. One is called Dijkstra's algorithm.
Yes.
I can't remember when Dijkstra lived, unfortunately, but I know that, okay, so it says 1930, right? But we didn't really get into computing until, or rather he died in 2002, apparently, born in 1930.
I was gonna say, I think it was the 50s, right? Yeah.
Yeah, but his algorithm sort of predates its usability in the sense that, computers weren't really around yet when he was starting to think about these ideas, right? And it probably was the inception of computing that got him to think about these ideas, but it predates a little bit. Maybe even a better example would be Boolean logic, right? Boolean logic is the foundation of computers, but Boolean himself is 200 years long dead or even more, right?
Yeah, exactly. Yeah, it's just kind of interesting how that happens. And it's cool to see that starting to happen, as you were saying, in the AI realm, as we, I think cloud, the other part of our event, Flow Factor, is about cloud computing. And I think that instantly available on demand scale that we haven't had really before, or the money to have before,
Mhm.
I think fuels that ability for, you and me without millions of dollars to be able to go to, GCP or AWS and try these things out, right?
Yep. This to me is
All
one of the foundational adjacent possible technologies, cloud computing, right? A lot of the clients that I have, they don't have the computing resources, they don't have the IT staff. And the reality is they don't need it. There are services out there and there are people that can help them get their idea out into the world just fine.
Awesome. Well, Dustin, that sounds like a great place for us to almost be done. Before we wrap up, I've been asking everyone to put together a little Easter egg, a question that you can put out there that we'd like those listening to this talk to think about. And then at Flow Factor, those that have heard this discussion can come up to you and say, I heard your question, or here's your question, and here's my thoughts on it. So I know we talked about this before we got started. Have you come up with something that you want people to think about?
Not per se, because I've been focused on the conversation. That said, what keeps coming to mind is I want to ask the question, what is your adjacent possible technology? What is an idea that you've been thinking about that requires more intelligence than basic mechatronics and robotics that you think could be a useful device in the world? Let's see if we can make that happen.
Awesome. I like it. And as we were talking, I was thinking the same thing. I guess because our conversation went that way. But awesome. Well, thank you so much for joining us today. And for those listening, June 11th, coming right up around the corner. Early bird ticket prices end on this Friday, although I think this video will be out before that on May 31st. But can't wait to see all of you June 10th. And thanks for coming.
Thank you.